But the case for repulsive gravity is quite strong.
And what would have caused it to coalesce? What would have caused it to compress initially? Why would all that matter? Be in this tiny, less than a pin-sized object?
So I have no idea, and nobody else on planet Earth has any real idea but we do have theories. And one of the theories suggests that in the very early universe, it was a highly chaotic environment, very hot, with all the fields fluctuating wildly up and down. And the idea would be that if you wait long enough, where it's hard to know what wait means in this environment, but don't press me on my definition of time back then, just sort of intuitively. If you wait long enough, on rare occasions, the energy will just happen to flatten out in a region, become uniform, and then that region explosively inflates, grows large. So, imagine you're looking at a pot of boiling water. The surface is, of course, wildly undulating up and down. But if you wait long enough, very long time, since you've never seen it, neither have I, there will be a little patch on the surface of that boiling water that flattens out. Why? That only means that the water molecules happen for an instant to be moving in just the right way to keep that little patch of water from wildly bubbling. It will happen, it's rare, but if you wait long enough, it will occur. Similarly, the widely undulating fields in the early universe, if you wait long enough, a patch will flatten out, you get the uniform energy, plug it into Einstein's equations, that region explosively inflates. And I mean explosively. It can go from a size that's much less than an atomic diameter to larger than the observable universe in far less than a blink of an eye, in 10 to the minus 30, 10 to the minus 35 seconds. That's how powerful repulsive gravity can be.
That is so baffling.
Yeah.
So before this happens, you just have, in this theory, you just have all of this energy sort of randomly interacting with other energy in the universe with no physical objects.
Yep.
And that could have been forever.
That could, and in fact, that's the main point. There's nobody who is hanging around looking at their watch saying, good God, when is this Big Bang gonna finally happen? So you can have this cosmological pre-show. You can have it last as long as you like. The only thing that you need to happen is that sooner or later, a region flattens out, and then the cosmological show begins.
And if we're looking at this model of the universe being this infinite universes with different characteristics and different qualities to them, this could be happening throughout infinity, all over the place.
Yeah, and in fact, this so-called inflationary cosmology is the technical name for the subject, says that. It says that it's quite likely that this explosive inflation of the region that we currently inhabit, it was just one of many such events. And therefore, there are other far-flung regions throughout this larger cosmological landscape where things have also inflated, but the details can be different. The physical details can differ from what we are familiar with. And the differences can be small, temperature differences in one part of space versus another, or they can be far more significant. Even the particles that make up that other realm may be different from the particles that make up our realm. Their masses can be different, their charges can be different, their fundamental physical features can be different. So out there in that wider cosmological landscape, it can be the wild, wild west of realities.
And they don't have to worry about proton deterioration.
There may be realms in which they don't have to worry about protons falling apart. The really crazy idea is that if you're very careful mathematically in analyzing these theories, you realize that there have to be realms out there that duplicate ours as well. Many can be different, but there have to be versions of this reality that are also instantiated, occur out there in other realms. So you come to these crazy sounding, sci-fi sounding ideas that you and I are having this conversation out there in other distant realms.
An infinite number of times.
Perhaps infinite number of times. And moreover,
Yeah.
small differences can also arise in these other realms where maybe our positions are interchanged at the table, or, maybe your name is, Joe Greene and I'm Brian Rogan, or there's like strange realities that can be taking place. And this is not an overworked theorist's imagination. This is the careful, dispassionate analysis of the mathematical equations. Now, I should say there are some physicists who see this implication and say, whoa, you guys have fallen off the deep end. Your theory has imploded, because any theory that predicts that kind of a wealth of realities that are kind of untestable because they're so far away that we will never interact with them, that's the kind of theory that we have been trained to avoid, to excise. However, the more forward thinking I'd like to describe us, physicists say, hey, math has proven to be a very valuable guide over the course of hundreds of years. And if this is where the math is taking us, it's at least worthy of our attention to investigate it fully and possibly come to the conclusion that this is how reality actually behaves.
Jesus.